Hello, Graham Walker's my name, from Walker Scientific, based in Perth. Dion's asked me to present a cyanide analyzer that we market throughout the world to laboratories for monitoring low-level cyanide in the gold process. I'm going to show you a slide presentation on the technology, which is called flow injection analysis. We'll be looking at explaining how we analyse it, and then we'll be discussing how you might be doing it already. This instrument is and has been increasing in I guess popularity as the nature of the penalties for discharge of cyanide into the environment becomes more onerous on the laboratory or the gold mine. So we'll call this talk the next generation of cyanide analysis. We've got installations in most of the gold-bearing countries of the world. The technology was developed by OI Analytical in Texas back in the 90s in conjunction with the University of Nevada at the request of Newmont Mining to enable gold mines to reduce dependence on things like titration and more particularly distillation for low-level cyanide analysis. Titration and distillation are very affected by interferences, and in the case of titration can be affected by personal habits and abilities. So Newmont wanted to get away from that and had this technology developed, and it's called flow injection analysis using gas diffusion and amperometric detection. My company's based here in Western Australia, but our territory is the whole of our region plus Africa. Next slide, please. Essentially, what we're doing is taking a filtered sample from either your bores or your detox plants or your discharge points, anywhere you need to monitor your cyanide at low level, which is typically for environmental applications. The technique for WAD in particular requires addition of what we call a ligand to get the cyanide into solution. We inject a known volume into an acid stream. Hydrogen cyanide gas is evolved and moves selectively across a membrane into a sodium hydroxide capturing solution. And it's measured by an amperometric detector, which is a silver-silver chloride reference electrode and a silver electrode. Silver and cyanide combine, releasing an electron, giving us a signal. So we essentially are eliminating, at this point, at the fusion membrane, all known interferences up to about 50 ppm of things like thiocyanate. So its benefits over titration and distillation are very low levels of interferences and very low levels of detection. So we can actually use this instrument to detect up to 10 ppm and down to ppb levels. Next slide, please. There are two instruments in our makeup, in our offerings. One is an online analyzer, the 9310. It is using exactly the same technology. We use a sample loop to inject a known volume of sample, passes into an acid stream, across this membrane, hydrogen cyanide gas is evolved, taken into an amperometric detector cell. There's a reference electrode and measured on the instrument. We don't have many of these in Australia, but we do have the next instrument, which is the laboratory machine. This uses exactly the same detection capabilities. We have the ability to run two chemistries on one platform, and this one instrument can run all three chemistries that the laboratory might need to run, both free, total, and available cyanide, or WAD cyanide. It's also a platform for running other analytes, but we're interested in cyanide today. So for free cyanide, we're measuring this species. We run that on the WAD channel, and the only change we make to the chemistry is the introduction of a buffer solution between 6 and 7 pH for the acidification solution, which we use for the WAD cyanides. Then we have another channel where we introduce UV digestion to enable us to break down the ions and cadmiums, and we can then do a total cyanide analysis. Most of my customers in the gold mines are looking for WAD analysis, which is these species here. So the analyzer can be run as a single channel, as a sequential dual channel, or a simultaneous dual channel. If I could have the next slide, please. As I've mentioned before, the detection ranges for the 9310 online machine are 2 parts per billion up to 10,000 parts per billion. We can run in the lab machine, I've calibrated out to about 80 parts per million, but the method states 5 parts per million. So we run a normal calibration for auditing purposes from 0 to 5 ppm with higher standards than that diluted down to the detector's range. Next one, please. The application for the online analyzers is similar to any online analyzers you might have in process control at the moment, where you want to control the level of cyanide in your plant. But our lab analyzer is what we're talking about more today. Next slide, please. This is a system where samples are brought into the laboratory, they're preserved in the field, brought into the laboratory, diluted to range, and then put into an auto sampler. A method is chosen, you push a button, walk away, and the analysis proceeds while you're doing something else. It's controlled by fairly nice new modern software where we designate an instrument, we create a sample table, we have a method, and we run samples. Not dissimilar to, say, something like an atomic absorption spectrophotometer, where you're calibrating, producing a calibration curve, using known standards and a routine daily method. Results are prepared and presented like this with a sample table. Again, not dissimilar to an atomic absorption spectrophotometer. 2 channels represented here. We're looking at standard calibration, a series of unknowns, and then a report. As far as reports go, we can export that a number of ways. We have the ability to print it directly to a printer. We have an export function here to either go out to LIMS or out to a Excel spreadsheet file on your desktop, on your computer. If you're running LIMS, which is, I guess, the feature of this seminar today, the ability to import is in here, the build sample table. We import a sample table, save that name, and when we run samples, we call up that sample table exactly as you've presented it from your LIMS system. Equally, when you finish the run, you export those results. You can save them in any format you like. So it is very LIMS friendly, and we have a number of instruments in Australia running LIMS on this machine. Next slide, please. Thank you very much. That's the FS 3700. Any questions?
Great, thanks for that presentation, Graham. We hear a lot about our customers using cyanide titrations in their laboratory. So can you tell me the advantages of why, flow injection analysis have you presented today, the advantages over cyanide titration?
Sure. Increasingly, gold mines are becoming subject to audits, particularly environmental audits. There's one side to the gold mine, which is the process side. That's where you make your money, so it's important to control your cyanide so that there's enough in it, in the tanks, to make sure you're not missing gold. But on the other side of the coin, if you're using cyanide, you are required by law not to discharge that into the environment. So what you're probably doing now, if you're not using flow injection, is titration, or perhaps even still distillation. The problem with those techniques, while they're cheap, is that they are highly erroneous, and with the case of titration, subject to interpretation by operators. So if you've got a need to improve the precision and the levels of detectability for your cyanide, if you're under pressure environmentally to control your cyanide, or you're spending a lot of money sending samples out to private laboratories in major cities, for instance, you may want to look at a lab-based on-site solution. Something like this, which has been called for by the larger gold miners for many years, and we've been increasingly installing. It's very accurate, low-level detection. It's not subject to interpretation by lab staff, and it's a dynamic technique, and it's a growing, internationally recognised technique for cyanide analysis. It's called flow injection analysis. The method is and was developed by the company I represent, OI Analytical, out of Texas. And the method that we refer to as OI1677, you can look up that in the method sheets. It's a very, very accurate, precise, and very timely method. If you're sending samples away, you may have to wait days. We can do this, we can run For instance, most of my gold mines run a morning and an afternoon sweep. It may not be a lot of samples, but you can have a whole batch of, say, 20 samples done in a couple of hours.
Yeah. Okay.
Big advantage. Thank you.
That's great. Yeah, so for anyone listening to the recording, if you want to get some more information about the instrument that Graham presented today, feel free to contact me at Datamine, Dion Bull at dataminesoftware.com, and I can refer you on to Graham, and he can have a chat to you personally about the instrumentation. So thanks a lot, Graham. Appreciate your time.
Thank you very much. Thank you.